look at today is used in all kinds of different applications because it's from the real world. It's an actual formula. So you may have seen it in physics or something like that. If this formula looks familiar to you at all, it maps an object's height based on the time the object is in motion. So usually it's like you throw something or drop something, it follows this formula. And I'm going to just go through and explain what the different things say. So this says h equals negative 16t squared plus vt plus c. You would fill in numbers for the v and the c in that formula. What the t is, that would stay your variable. T is the time that the object is moving. So, you know, if we drop something, we throw something, whatever, the t is the time the object is moving along its path. And that's going to be in seconds. V is the initial upward velocity of the object, which is a fancy word for the speed or how fast the object is going. And that's got to be in feet per second if you're using this formula. I'm not going to give you anything weird where you'd have to convert anything like that. And then C is the initial height of the object. And that's going to be in feet. Now, in terms of like what this would look like on a graph, we're going to go through that in a second, but the coordinates of the points would be in the format where you guys are used to seeing X is T for the time, and where you guys are used to seeing Y, this is going to be H, which is just the height the object is at that time. Now, I should have left a little space for this, and I totally didn't, so let me just ask you this. Negative 16 is the very first piece of this equation. Does anybody know what the negative 16 is? Anybody take physics at all know this? Okay, if I throw something or drop something, what force brings something back to the ground? This is gravity. Okay, so the negative 16, this is the force of gravity in feet per second. So that's why you'll always see negative 16 in this formula. There's another formula really similar to this that's in meters per second. I don't think I have anything that we're going to use that for that I can think of, but the only difference is that beginning number would be negative 4.9. But for feet per second, if we're working with time in seconds and height in feet, the negative 16 is just the force of gravity in feet per second. So that's why you'll see that in that equation. All right, so the first thing we're going to do is we're going to get a situation. We're just going to write this lovely little equation. So this says a toy rocket is launched upward with an initial velocity, so that's my V in the formula, of 40 feet per second, and the toy rocket is on a table that's 3 feet off the ground. So let me just try and start to write this. So the height of the toy rocket is negative 16t squared. The height is going to be that 16 is the gravity. And then the middle term is just to substitute in the 40 feet per second. That also has a t attached to it, but that one's not squared. And if I launch the toy rocket off a table that's 3 feet above the ground, what is my c value? The 3. That's all that is. So if you're not launching it from the ground, that initial height, that's your c value. Okay, so we're just, okay, this is not to scale or anything like that. We're just going to take a general picture here. So the time would be your x, and the height would be your y. I don't have any labels on this at all because we're just going to kind of sketch this. If you look at the equation, would the quadratic, would it be like right side up like a U shape or an upside down? Why? Right, how could I tell just from looking at the equation though? The negative. Okay, yes, so the rocket you're going to launch in the air and gravity is going to drag it back down. So the path would look like an upside down parabola, but if you just had the equation, you would know it has to turn upside down because of that a value being negative. Okay, now, this is, I guarantee this is not to scale, but I'm going to put a little 3 on the y-axis because that's the initial height. So we're going to launch this up in the air, and then it's going to come back down. And on my picture, does anybody know why I'm not going out of the first quadrant? Like, why do I stop on the x-axis? Right, it would go underground. The ground is going to stop it. It's not that powerful. It's a toy rocket. Okay, so it's going to stop on the ground. So basically, the x-axis would represent the ground in terms of the height of the object. Okay, how would you figure out the height of the rocket after 1 second? Hunter, what do you think? Yes. So you're literally just going to put this in. You can use the gravity and everything too. Just put this in for, they're giving you the time. So we're just going to multiply that by the -16. We're going to multiply that by the 40 and add the 3. So you're just going to plug it in. So this is where I would maybe, we could do this by hand, of course, but if you want to grab your calculator, that's what I'm going to do. So everywhere I see a time, I'm going to plug in a 40. Okay, now, and I'm just going to make this steel to you guys, because I don't know why, but for some reason, sometimes when people do this, they forget the squared. I don't know why. When I've just noticed that as a common mistake. So don't forget on that first term, -16, I'm literally going to type it in exactly like I have written it. You are not squaring -16. You are squaring 1 and then multiplying it by -16. So if you just type it in right like I have it with little parentheses just above the 8 and 9 key if you're working with your calculator there, should take care of it for you. But don't forget the squared. I don't know why people sometimes will forget that when they type that into the calculator. So this would be 27. This is the height of your object. The time is in seconds, and then the answer where you guys are used to seeing the y is actually the height of the object. So after 1 second, it'd be 27 feet in the air. All right. The next two questions are kind of related. So it says, in how many seconds will the rocket reach its maximum height? And then it says, like, what is the maximum height? So this is asking you for time. And this one is asking you for height. And if you remember what I told you at the top, all the points on that graph, the x-coordinate would be the time, and the y-coordinate would be the height that the rocket's at. What am I going to do to figure out, like, what time it reaches the maximum height and where the maximum height, or what the maximum height is? Like, where would that be on the graph, the maximum? Exactly. If this is just the vertex. Okay, so I'm sure this is not to scale, this is just a sketch, but if it asks you for maximum or minimum, it's trying to get you to find the vertex. So, if we have, I'm going to pull this back down so we can see our lovely little formula. I have a formula here for the height of the object based on time in standard form. How would I find the vertex of the parabola if it's in standard form? Do you remember? We could convert it to vertex form. How would I do that? Like, how would I find the vertex? Does anybody remember? You can't see the vertex in standard form. I can see the y-intercept is 3. Does anybody remember the tiny little formula you used to find the x-coordinate of the vertex? Yes, yes. Okay, so this is, all this is right here. This is -b over 2a. That'll give you the x-coordinate, which is the time. And for this part, you're just going to plug in -b over 2a, because it'll give you the time for part B, and then to get the height, we're just going to plug that in. Now, I want to emphasize something here, because this is where people will screw stuff up. You have to figure out what the bottom of that fraction is before you do the division. All right, if I'm looking at my lovely formula, right, opposite of b would be -40. The bottom of this would be 2 times -16. Okay, now I'm going to show this to you. Just don't write this down. If I do -40 and I divide that by 2 and I multiply that by -16, right, I'm just typing that in, it gives me 320, which means it would take 320 seconds for this toy rocket, like almost 6 minutes, which makes no sense, for that to reach its maximum height. If I did this correctly, though, I just want to take and put the bottom of that in parentheses. What I really should be doing is dividing -40 by -32, So that makes more sense. So just be super careful with that, because I see people do that a lot of the time. What I usually do is I actually just go ahead and multiply 2 times negative 16, and then I would type it in my calculator there. The negatives are going to cancel each other out on that, so you should get 1.25 seconds. And that's the answer for part B there. If you wanted to, I'm just going to come over to my graph here. So I know this is 1.25 seconds would be the x value there. And then to get that height, we just have to plug that in. So everywhere I see a t for the time, I know the time is 1.25 seconds. Just don't forget the squared here. And then plus our velocity was 40 times that time, 1.25. And then we're going to add 3 to that. And then again, I'm working with decimals here, so I'm just going to grab my calculator. Don't forget to square that first term. I don't know why people forget the squared on that. And this is going to be 28 feet. So that would be the point, 1.25, 28 would be your vertex if you were looking at that graph. So the maximum height is the 28, the 1.25 is the time it takes to get there. So the 28 is the answer for part C, and the 1.25 is the answer for part B. This is just x coordinate of the vertex, y coordinate of the vertex. That's all it is. If you're asked for a maximum, that's what it is. And let me convert this to vertex form really quickly. So I should have typed this on here, but here's my vertex form. It's just, in our case, the y is the height of the object and the t is the time. So I'm going to go ahead and write it in that form. So my height is, if you guys remember, this is nice for us. The height up here has an a value in the standard form, or that relationship is negative 16. That a value is the same in both forms. So this vertex form would have that negative 16 in front of it. Okay, now in the parentheses, instead of writing x, I'm just going to write t, because we're talking about the time here. And I just need to grab the x coordinate of the vertex, which is what we did in part B, that 1.25. So it'd be minus 1.25. Don't forget to square that, because that's what gives you the quadratic. And then outside of that goes the y coordinate of the vertex. That was our answer for part C, which was the 28. And that's all you have to do. If you have the vertex, you got to grab the a value from that original standard form equation, but then if you've got the vertex, you just plug it in for your h and k. Does anybody have the question? Okay. Now, this one does not have the nicest numbers. So this says a football is punted into the air with an initial upward velocity 73 feet per second. So this is my velocity here. Initial height, that's your C value from that formula at the top of the page. Write a function to model this. So we're just going to do this. Height, negative 16 is the gravity, t squared, plus 73t, and then plus 2.5. All you got to do. Now, it says, in how many seconds will the ball reach its maximum height? Again, because this is negative 16, I know this parabola is going to turn upside down if we were to have a visual of this. And the maximum is just going to be the vertex. So all you have to do, the time, again, the point is time and height. So how many seconds? This is asking you for time. This is just negative b over 2a. And what is the maximum height? This is your height, obviously. This is what you get when you plug in whatever that negative b over 2a is. Now, I'll tell you up front, the negative b over 2a here is a garbage number. So this ends up being, opposite of b would be negative 73 divided by 2 times a, which is negative 16. So almost all these questions, if you're working with this formula, the bottom of that fraction should be negative 32. So I usually just write that in so that way I don't make a mistake. So the 73, I'm going to divide that by 32. The negatives will cancel out. And you guys can see I didn't get the greatest number here. So I'm just going to go ahead. And actually, if you want to leave it as a decimal, or as a fraction, you totally could do that. But I don't want to round here multiple times as I'm doing the problem. So I'm going to write that out. If you want to, you could just write like 73 over 32 seconds. That's an exact value. That's what I want to use to plug in to get the actual height of the object, which I'm going to do in the second part of the question. So either one of these, if you get a nasty decimal like that, if you want to use the fraction or if you want to write out the decimal, it's totally up to you. To do this part then, I do -16. I'm just going to go ahead and use that fraction. 73 over 32. That's squared. And then it's plus 73 times 73 over 32. And then plus 2.5. This is not a nice number either. So don't think you're doing anything wrong if you get a decimal on any of these. And if I plug in that fraction, I'm just getting an exact value here, not rounding multiple times. Alright, so I'm not going to write out all those decimals there, but I'm going to say this is about 85.8 feet. Is anybody having a question? It's not horrible. It's just asking you for the vertex if it's asking you for a maximum. Okay, I have a little tiny bit more I'm going to ask you about this problem, but it's really similar. So this says Bree hit a golf ball from the ground. Initial velocity of the golf ball is 80 feet per second. I'm just going to write that formula real quick so you guys can see it at the top of the page that we were working with on the front. Okay, so she hit a golf ball, initial velocity 80 feet per second. She hit the golf ball from the ground. What would the equation look like here? If you plugged in the velocity and the initial height, what would you write down? Somebody raise your hand and tell me. So it would be height equals, we got to have the -16, that first term doesn't change because that's just talking about gravity. What would you plug in for V and what would you plug in for C? Riley, what do you think? Why? Exactly. Okay, she said plus nothing, right? Now, if it goes from the ground, that just means the initial height would be 0 because you'd be on the ground, so you would not have a constant term there, and that's completely fine. If I was graphing this, what would the y-intercept be? 0, 0. You're going to start from the ground, right? And we know, so she's going to hit this golf ball in the air, and I know it's going to be an upside down parabola because of the -16 there, so it's going to go something like this. And I'm sure this is not to scale, we're just sketching this, all right? So how long will it take for the ball to reach its maximum height? This again, this is asking you for time, and this is just -b over 2a. So for this question, it'd be -80 opposite of b, 2 times -16, so -80 divided by -32, which is going to be 2.5, and that's in seconds. I'm just going to come over, oh, my parabola looks really pathetic here. All right, I'm going to come over here, right in the middle of the x, here where I drew my parabola. The x coordinate of that vertex would be 2.5 seconds. What is the maximum height? All we got to do is take and plug in 2.5. So I do -16 times 2.5 squared times 80 times 2.5. Did anybody do that on their calculator? Can you tell me what it is? What'd you get? 100. Okay. This would be feet, so that's going to be the maximum height of this lovely golf ball. So I'm sure this is not drawn to scale. Okay, now this is kind of an interesting question because I'm going to ask you for a domain and a range here. And normally just the domain of a parabola is -infinity to infinity, right? But this has a scenario attached to it. So we have a situation here. So the domain is not going to be -infinity to infinity. If it was -infinity, we would have negative time, and if it went to positive infinity, it would also be it would represent positive time, but it would represent a negative height, which doesn't make sense. What would you tell me? And this is kind of tricky. What would you tell me the possible time values are here? What do they go between? Okay, she says 0 and 5. Totally right. And I'm going to use brackets here. We don't usually use brackets, but we're going to because we have an actual point here. We have an actual point here. How did you know this was 5? Perfect. Okay. So because this we couldn't have done on the question on the front because it had an initial height, but since I'm going from 0, this distance is 2.5, this distance is a mirror image because that axis of symmetry is going right through the middle, so this has to be 5. Right? So basically what that means is the ball would come back down to the ground after 5 seconds. All right, what would you guys tell me a reasonable range is? Like, what are the possible heights that this golf ball goes through? What do you think? Exactly. Starts on the ground, the maximum height is 100, and it comes back down to the ground, but it never goes above 100. Okay, now, how high up in the air is the ball after 1.5 seconds? So we're just going to plug this in. So I'm going to do negative 16 times 1.5, not forget to square it, plus 80 times 1.5. And I feel like this is a nice number, but I don't remember what it is. I'm just plugging in 1.5 everywhere I see a T for the time. I got 84. This would be in feet. So I don't know. I'm just going to kind of eyeball this on my paper. It doesn't have to be perfect. So after 1.5 seconds, I'd be at 84 feet. Okay, now right next to this, it says, will the ball reach that particular height, 84 feet, at another time? So here's my golf ball going up in the air. Here I hit 84 feet. Would I hit 84 feet at another time? Rudy, what do you think? Exactly. So I'm on the way up, and I gotta hit that on my way back down. I get up to 100, but then I gotta come back down to the ground because of the gravity. Does anybody know what time it would, like how many seconds it would be? Jonathan, what do you think? 3.5. How'd you get 3.5?
Because if it goes from 84 to 21 seconds, to come back down, that's the top 1 second.
Exactly. What were you gonna say, Hunter? It would, based on the equation. Yeah, because the gravitational force is consistent. Yes, that's a really good question. So there's couple ways you could figure this out, but the distance here between the axis of symmetry and that 1.5, this distance is 1. So it would have to be a mirror image distance of 1 here. Then you can add the 3.5. The other way, so this would be 3.5. 84 here, based on my lovely picture. The other way somebody did that last period, which I also thought was interesting, they said, okay, well, bless you, this was 1.5 seconds here, so they knew this piece would have to be a mirror image, so they did 5 minus 1.5, which would give you the same thing, but 3.5 seconds. We're just using symmetry there. That axis of symmetry is right in the middle. Again, you cannot use this axis of symmetry, though, unless this starts on the ground. If it was one of the questions we did on the front, it would not quite work that way, so it has to start on the ground for you to use that symmetry to figure out other times and other heights. Is anybody having a question? Okay, now I have one more, and this is really different than all the other problems that we've done today, but we're still going to maximize a quadratic on this. So don't judge my drawing. All right, it says a farmer plans to make a rectangular garden that's going to be next to a barn. So here, just pretend I am a fabulous drawer when I am not, and this is the barn. Okay, now it says one side of this garden is going to be against the barn, so we would not have to use fencing for that side because we could just make sure it connects to the barn. All right, so I'm just going to draw a rectangle using the barn as one of the sides. So if we're working with a rectangle, and you can use whatever variables you want. I'm just going to use x and y. So I'm going to call like the top and the bottom x, and I'm just going to call that right side the way I drew that picture y. I don't need another y here because I wouldn't have fencing against the barn, so it's going to save me some space. Okay, now it says the farmer has 100 feet of fencing. What are they giving me if they say I have 100 feet of fencing? Exactly. It's a perimeter, right? It's the perimeter. So the 2x plus the y, if I add up around the outside, that should be equal to 100. Okay, now it says, what are the dimensions of the garden that will maximize the area? This is talking about the perimeter. How would you find the area? What would you do?
You're going to find what the perimeter is first and multiply x and y together.
Yes, we got our perimeter, right? We're going to multiply x and y together to get our area. Now, you got too many variables going on here. Here's what I would tell you to do. You're going to utilize the perimeter here to get one of these variables by itself. Easiest way I could do that for this particular question. Let me just subtract the 2x. So I would have y equals, I'm going to write negative 2x plus 100. Okay, now the reason I'm doing that, I'm going to sub this in for y in this equation. And that'll create the one side only having one variable, which will be x for this particular example. You could do either one, doesn't matter. But to find my area, I'm going to have x times negative 2x plus 100. So if I simplify that, what would you write down for your area if you simplified that using the distributive property? Hunter, go ahead. Perfect. When you multiply that, that's what creates the quadratic, because now I have an x squared, right? Now, if you guys thought about this parabola, it starts out with a negative number, so I know it has to go upside down. So all the points on the parabola, we're not going to graph it or anything on a coordinate plane, but all the points on that parabola would represent possible x value that would give me an area. So the way this would work out, every point here, x would be the length of the side in that picture. The y coordinate would be the actual area that it would enclose. So there's a bunch of different options here, but we want to maximize the area. So I would just need the lovely vertex here. So I'm just going to do negative b over 2a. That'll give me the x value. And there's a couple different ways you could get the y value and a couple different ways you could get the area. But if I do that, opposite of b would be negative 100 over 2 times a, which is 2 times negative 2. So this is negative 100 over negative 4, which is the lovely number 25. Now, that's not the area, that is the x-coordinate of the vertex, which would give me this distance. So back in this lovely picture over here, these two sides would both be 25. And to get the y value, I am just going to plug 25 right in there. So the other side of that fencing, we'd have negative 2 times 25 plus 100, which would be negative 50 plus 100. So this side would be 50. So if they ask you, they just ask you for the dimensions of the garden that would maximize the area, I would say this is 25 by 50. Is what would maximize it. Those are the two dimensions. It doesn't ask you for the area, but you could figure it out if you did 25 times 50. Or the other way, you could actually plug it into that equation we had. Do the negative 2 times 25, it'd be squared, plus 100 times 25. It gives you exactly the same thing. So there's kind of two ways you could get the area if they asked you for that. You can either just do length times width, base times height, or you can plug that into that lovely quadratic we created. That'll give you the area. And I know it doesn't ask you for this, but I'm just going to jot it down. So this would be 1,250 square feet. Is anybody having a question? There's one problem like this on the homework. Okay. Yeah. In terms of the homework assignment here today, we're going to